Hello, in this video we're going to start looking at what it means to factor polynomials. And the very first type of factoring that is useful is using common factors. So let's consider two monomials, which could be terms of a polynomial, and that's how we're going to build this basically. I've got 12x to the power of 5y squared and minus 30x to the power of 3y to the power of 7, and I want to know their greatest common factor. Now, if I were just finding the greatest common factor of 12 and 30, one of the ways that I could do that is consider their prime factorizations. So 12 as a prime, like written as a product of prime factors, is 2 squared times 3. And 30 is 2 times 3 times 5. These are the prime factorizations. Now, because I'm dealing with negative 30, I can also include a factor of negative 1. That doesn't really change too much of my process. And now if I consider that I'm actually also working with variables, I could essentially consider each of these variables, x and y, to be their own prime numbers. Now they might not be prime numbers, but as far as I can tell they are, so they're sort of indivisible. So the overall factorization I could consider to be 2 squared times 3 times x to the power 5 times y squared, where x and y are separate factors, and negative 1 times 2 times 3 times 5 times x cubed times y to the power of 7. Now remember, the greatest common factor was the product basically of all the factors that these have in common. So any common factor is any factor. So 3, for example, is a common factor. X squared is a common factor of both of these terms because I can divide both of them by x squared and have nothing left over. But the greatest common factor is going to be the product of everything they have in common. So in this case, that would mean that I have, I have a common factor of 2, but only one of them. I have a common factor of 3. I'm not going to include the negative 1. I could include the negative 1 because technically I can also divide 12 by negative 1. Sometimes I will include the negative when I'm dividing polynomials, but that'll become clearer a little later on. So as far as numerical common factors, 2 times 3 is it. 6 would be the greatest common factor of 12 and 30. But as far as variables, I also can include x cubed because I can divide x to the power of 5 by x cubed, and I can divide x cubed by x cubed. And I would include y squared for basically the same reason. So the GCF in this case is 6x cubed y squared. So that's going to be handy when I start wanting to factor polynomials. What essentially I'm going to look for, now I've got those two things combined in a single polynomial. They are terms in a binomial. I can factor it by saying, well, what can I divide both of those terms by? What is the greatest common factor of both of those terms? And that's 6x cubed y squared, as we previously discussed. So what's left, the other factor of this polynomial, is what I get when I actually divide each term by that greatest common factor. So 12x to the power of 5 y squared divided by 6x cubed y squared leaves me with 2x squared. And negative 30x cubed y to the power of 7 divided by 6x cubed y squared leaves me with minus 5y to the power of 5. There are no longer any common factors between 2x squared and minus 5y to the power of 5. And what I've got here are the two factors of this binomial. It can be expressed as 6x cubed y squared times 2x squared minus 5y to the power of 5. So this is considered the factored form of this polynomial. So looking at a few more examples here, if I have 12x plus 26, I'm asking myself, what is the greatest common factor of both of these terms? So 12 is 2 times 2 times 3, 26 is 2 times 13. So I can divide them both by 2. That's the biggest thing I can divide them by. And when I do divide by 2, I get 6x plus 13. 6x and 13 share no more factors, so no more common factors other than just 1, but dividing by 1 doesn't change anything. So these are the two factors. There's a monomial factor and a binomial factor of that original binomial. For 5x cubed minus 15x squared plus 35x, all three of these terms can be divided by 5x, leaving me with x squared minus 3x plus 7. So in this case, I end up with a monomial factor and a trinomial factor. Now, sometimes it's a little more complicated than that. This is when we're going to use something called regrouping. Because when I look at this a 4-term polynomial, there are no common factors to all 4 terms. 6 can be divided by, so I don't have an x in this last term, so I can't divide by any powers of x. 6 can be only divided by 2, 3, or 6, and while 8 can be divided by 2 and 21 can be divided by 3, neither of them can be divided by the same thing. So I can't actually divide all 4 terms. But what I do notice sometimes is that if I group this in pairs, I do have common factors for each pair. So the greatest common factor of 6x cubed minus 8x squared is 2x to the power of 2. And when I divide that out, I get 3x minus 4. And the greatest common factor of 21x and minus 28 is 7, so plus 7. And when I divide that, I get 3x minus 4. Now the key here is that when I divided out those common factors in the pairs by the grouping, I was left with now another common factor. So 3x minus 4 is now the common factor of this whole first term and this whole first term. So I can factor out that common factor of 3x plus 4, or minus 4, sorry. And when I divide by 3x minus 4, what is left is 2x squared plus 7. So by doing that technique, I was able to take this 4-term polynomial and express it as the product of 2 binomials.